Hello and welcome. I'm Saeed from StoryPlanet.net. Dive right into the essence of the most captivating books without reading them cover to cover. Whether you're on the go, at the gym, or just relaxing at home, we offer you a unique and enriching listening experience. Today, we are exploring the book Helgoland, a creation by Carlo Rovelli. Helgoland, 2021, delves into the ethereal and lyrical realm of quantum mechanics, unveiling the uncertainties of the mysterious subatomic universe. Before we delve into these revelations, it's interesting to note that Carlo Rovelli, a theoretical physicist, leads the quantum gravity research group at the Centre de Physique Théorique in Marseille, France. He is the author of popular physics books such as 7 Brief Lessons on Physics, Reality is Not What It Seems, and The Order of Time. With 7 key ideas to unveil, brace yourself for a deep dive into this captivating book. On StoryPlanet.net. To start, summary. An examination of the latest developments in quantum physics, focusing on its relevance and potential benefits for individuals. In the summer of 1925, physicist Werner Heisenberg, seeking relief from hay fever on Helgoland, ponders deeply on atoms. His thoughts revolutionize physics. Physicist Carlo Rovelli's storytelling uncovers the development of quantum mechanics, revealing Heisenberg's contributions to understanding subatomic particles, which still puzzle scientists. This narrative explores the link between hay fever, quantum mechanics discovery, the nature of objects, and the unnecessary nature of multiverses. Key idea number 1. Heisenberg pioneered quantum physics, a new and complex field of study. In the early 20th century, physicists like Niels Bohr and Heisenberg discovered phenomena related to the behavior of electrons in atoms, leading to the development of quantum physics. Heisenberg focused on observable properties like light frequencies, leading to complex matrix calculations that matched Bohr's observations. Schrödinger approached electrons as waves, matching Bohr's observations but struggled with the particle-like behavior of electrons. Max Born proposed the idea that Heisenberg's calculations explain outcomes, while Schrödinger's describe probabilities, leading to the concept of electrons existing as waves until observed, then collapsing into particles, raising further questions. Key idea number 2. Superpositions challenge our understanding of reality. Schrödinger's cat experiment illustrates quantum superposition, where contradictory properties exist simultaneously. Scientists have proven superpositions occur, such as light behaving like it takes 2 paths. Interpretations like many worlds theory explain this. Hidden variables theory separates Schrödinger's wave and quantum particle, suggesting the probability is real in an unknown way. Quantum Bayesianism sees superpositions as incomplete information shaped by observation, raising questions about the observer's role. Key idea number 3. The relational interpretation describes a dynamic world where everything is constantly changing. The relational interpretation of quantum theory suggests that the traditional concept of observation is not limited to sight and humans. Instead, all entities in the universe are both observed and observers due to continuous interactions. Physical systems exist and acquire properties through these interactions, forming a network of relationships. Properties and information are constantly changing depending on circumstances, emphasizing a dynamic and interconnected view of reality. The theory challenges the idea of a clear separation between observed objects and observers, showcasing a world in constant flux and interconnectedness. Key idea number 4. The relational model explains quantum entanglement. 2 entangled photons in a superposition state exhibit quantum entanglement, where their properties correlate even at a distance. The relational model explains entanglement as properties only existing through interactions, not across space. Observations in one location influence the state in another, showcasing a network of relations rather than a mysterious link. Key idea number 5. Philosophy and science are closely connected disciplines. Ernst Mach, an influential scientist and philosopher, proposed that the world consists of sensations, influencing physics, arts, and politics. He challenged the dominant mechanistic view, advocating for observable phenomena and the interplay between science and philosophy. Mach's ideas on interactions and sensations resonate with quantum theory, influencing thinkers like Heisenberg. His perspective highlights the importance of interdisciplinary collaboration between science and philosophy, showcasing how new insights can emerge from exploring the connections between disciplines. Key idea number 6. Understanding relations and correlations can help us gain insight into the functioning of the mind. Various misinterpretations and misapplications of quantum concepts are prevalent in areas like spiritualism, healing practices, and tech, sparking imagination. Quantum theory cannot fully explain life's profound questions like love or beauty. Still, applying relational quantum theory to topics such as consciousness can lead to new investigative paths. Relational quantum theory emphasizes relationships and correlations, shedding light on cognitive processes such as intentionality. Intentionality arises through relevant relative information, which correlates external and internal systems. While this explains physical processes, understanding subjective experiences remains challenging, known as the hard problem of consciousness. Key idea number 7. Studying quantum physics offers new perspectives on the world. The traditional model of sight suggests eyes capture light, bouncing off objects, which the brain interprets into an image. However, an alternative view proposes the brain predicts what the eyes should see, utilizing discrepancies to understand the world. Quantum physics reveals new perspectives on reality, suggesting our consciousness is constantly refining preconceived notions against sensory data. Science follows a similar process, where theories evolve through testing and refinement, including current understandings from relational quantum physics. This view portrays a dynamic world of interactions, challenging traditional notions of stable entities. Our very identities are shaped by this ever-changing network of relations. Embracing this unconventional perspective opens up new paths for exploration and understanding. In conclusion, physicists in the early 20th century shifted from classical to quantum physics, challenging determinism with uncertainty. The relational interpretation suggests reality depends on dynamic, unstable relations. Feedback on the content can be sent to remember@storyplanet.net with Helgoland in the subject line. Thank you for listening to this summary. If you enjoyed this exploration, we invite you to discover other fascinating books on storyplanet.net. Don't wait any longer. A multitude of books, stories, and knowledge await you there. See you soon on storyplanet.net.